So let's get right into it. Today, we're going to talk about a really clever AI model called MinerU 2.5. And what's so special about it? Well, it's tackling one of the toughest nuts to crack in AI. How do you teach a computer to actually read and understand our most complicated documents? I mean, just think about it for a second. Where is all of our most valuable information? It's not sitting in some perfectly organized spreadsheet. Nope. It's trapped inside things like scientific papers, dense financial reports, old historical archives, PDFs. And getting that knowledge out is a huge, huge problem. And you might be thinking, why is that so hard? Can't computers just read? Well, it's not that simple. See, documents are a total mess for computers. You've got columns, you've got those tiny little footnotes, super complex tables, and don't even get me started on mathematical formulas. It's an absolute nightmare for a standard AI. This isn't just about recognizing letters on a page, it's about understanding the entire structure. Which brings us right to the heart of the problem. It's something the researchers call the high-resolution dilemma. And honestly, it's a fundamental trade-off that's been a real headache for developers for a long, long time. Okay, so here's the deal. To really read the fine print, the tiny text in a footnote or a complicated formula, the AI needs to see the page in super high resolution. But, and this is a big but, trying to process a whole page at that level of detail is just ridiculously slow and costs a fortune in computing power. It's like trying to stream an 8K movie on an old dial-up modem. It just doesn't work. So how did we used to handle this? Well, the old methods were not great. You basically had two options. First, these traditional pipelines. Think of it like an assembly line, where each AI does one small job. The problem? If one makes a mistake early on, the entire thing is ruined. Then you had the other extreme, these giant end-to-end models that tried to swallow the whole document in one go. Total overkill. It's like using a sledgehammer to crack a nut, just wildly inefficient. All right, so with those two pretty bad options on the table, this is where MinerU 2.5 enters the picture. It brings a completely different, much smarter strategy. It shows us that this isn't about raw power. It's about being clever and efficient. And get this, the model is only 1.2 billion parameters. Now, in today's world, where we're used to hearing about models with tens, even hundreds of billions of parameters, that is tiny. And that's what makes its performance, which we're about to see, so absolutely mind-blowing. So what's the secret sauce here? How does it do it? Well, the creators themselves put it best. The key innovation is a decoupled architecture. All that means is they brilliantly separated the big, hard problem of understanding the entire page layout from the more focused job of just reading specific little pieces of it. Probably the easiest way to wrap your head around this is to think of it as a skim then read solution, which, when you think about it, is pretty much exactly what we do as humans. Okay, so let's walk through this because it's so intuitive. Step one is the skim. The AI takes a quick look at a blurry, low-resolution version of the page. It's not trying to read any words. It's just getting the lay of the land, right? It's thinking, okay, looks like a header up top, a big chart over here, and a couple columns of text. Then, once it has that map, it moves to step two, the read. It goes back to the crystal clear high-res image and zooms in only on those important parts it identified to do the actual reading. Smart, right? Now, the fancy technical name for this is a coarse-to-fine strategy. And the genius of it is that it stops the AI from wasting a ton of energy and computing power on all the empty white space on a page. It focuses all its firepower exactly where it matters. It's just elegant. And, as we'll see, incredibly effective. But, a clever design is only one piece of the puzzle. The other half of what makes this model so successful is the super smart way they actually trained it. Okay, this part is just brilliant. They have this training method called iterative mining, or IMIC. Here's how it works. The system has the model try to understand a document a few times. If the model keeps giving different answers, it's a sign that it's confused, right? So the system flags that document as a hard case, and those are the ones that get sent to actual humans to be labeled perfectly. It's such an efficient way to find the model's blind spots and teach it exactly what it needs to learn. So you've got this smart architecture. You've got this even smarter training method. So the million-dollar question is, does it actually work? How does it perform in the real world? Let's put it to the test. How does this relatively small, specialized model do when it goes head-to-head with the giants? We're talking about the big, general-purpose models from places like Google and OpenAI. And here are the results. It's pretty incredible. On OmniDocBench, which is a really tough test for this kind of thing, MinerU 2.5 doesn't just hold its own, it flat out wins. It beats the much, much larger models like GPT-4o and Gemini 2.5 Pro. It's literally the new state of the art.
And if we drill down a little deeper, you can see it's not a fluke. The story holds up. Whether it's recognizing plain text, complicated formulas, or messy tables, it gets top scores across the board. This just proves that its specialized, super efficient design gives it a real decisive advantage for these kinds of specific, complex jobs.
Okay, so the scores are impressive, for sure. But what does this actually mean for us? Why does this matter? What does a breakthrough like this actually unlock? Well, the real-world applications are just massive. For one, it can totally supercharge something called Retrieval Augmented Generation, or RAG. That sounds complicated, but it's basically the tech that lets chatbots like ChatGPT look up information in real time from a bunch of documents to give you up-to-date, accurate answers. Before, they could only really read the text. With this, they can understand the tables, the charts, everything. Beyond that, think about automating data entry, digitizing massive historical archives, and even creating way better data to train the AIs of the future. And this last quote from the researchers really hits the nail on the head. By being able to turn these messy, unstructured documents into clean, structured data, MinerU 2.5 isn't just another cool app. It's a foundational tool. It's something we can use to build the next generation of even smarter AI. So all of this leaves us with a pretty profound question to think about. For hundreds of years, our most important knowledge has been locked up in books and papers, formats that are easy for us to read, but basically impossible for computers. Now that wall is finally starting to crumble. So you have to wonder, what's waiting for us inside all those millions and millions of pages? What knowledge are we about to unlock?